The liquid water environment under Europa's icy shell may be conducive to supporting life. Europa Clipper hopes to observe unpredictable, dynamic processes, such as thermal and compositional anomalies on the surface. But with the spacecraft up to 1 billion kilometers from Earth, fast, round-trip communications are not possible. How best then to detect and react to such interesting but transient events?
We've created data analysis methods to run on board the Europa Clipper spacecraft and detect interesting events at the point of data collection. The great thing about that is that it can inform decisions about which data should come down to Earth first, and also inform plans for how to coordinate observations between two instruments.
During each Europa flyby, Europa Clipper will collect most of the data in just a few hours, and then spend the next 2 weeks sending hundreds of gigabytes of data back to Earth.
eThemis is the Europa thermal emission imaging system. With eThemis, we can search for thermal anomalies on the surface of Europa, where new material from beneath the surface has either been exposed or erupted. Since no data exists yet for eThemis, we've generated simulations of what the instrument will see when it reaches Europa. Even a simple threshold-based approach is capable of automatically identifying hotspots on the surface.
We can also identify the spectra of exotic materials using the MISE imaging spectrometer.
MISE stands for the Mapping Imaging Spectrometer for Europa. Imaging spectrometers like MISE can generate a huge amount of data that we don't have the ability to return to Earth. Onboard autonomy could allow us to do a more comprehensive search of Europa for these high science value areas.
ICE stands for Europa Imaging System. We can search ICE camera data for diffuse water plumes erupting from the surface by finding the limb of Europa and searching for bright regions above the surface. We have previously seen water vapor plumes on Enceladus and volcanic plumes on Io, and we can use these observations to evaluate our algorithm. These plumes would tell us a lot about the subsurface ocean and its potential for harboring life.
This would allow the cameras on Clipper to search much more broadly for plumes. We would be able to look at additional times, locations, and lighting angles, and that's important because we don't know exactly when or where these eruptions might be occurring.
This work provides an example of how machine learning can help transform spacecraft from passive data collectors into active agents of space exploration and discovery.